On 3rd of August, I will continue with the yesterday's content. Yesterday, we solved differential equation of linear SHM and we found the general expressions for acceleration, velocity and displacement. Acceleration A is a function of displacement. A is equal to in magnitude omega square x. Velocity v is also the function of displacement. V is equal to plus minus omega square root a square minus x square. So here displacement is the major term. The basic equation, the general expression for displacement, x is equal to a sine omega t plus phi. Omega is angular velocity and phi is called an initial phase or it is also called epo. The term omega t plus theta is called angular displacement. And in short, we can write displacement x as a sine theta. So this theta, which is omega t plus phi, is called angular displacement. And this term always explains the state of oscillation of particle in linear SHM. This theta gives you the position and the direction of motion of a particle performing SHM, linear SHM. So at instant t, theta determines the state of oscillation and thus is called phase of SHM. So it is given on page 118 page open karo. The angular displacement theta is called phase of SHM. So you may get question, define phase of SHM. So it gives you the position at the given instant t and its direction of motion and describe the state of oscillation and hence called phase of SHM. Suppose initially theta is 0, ये वैल्यू अगर 0 होती है, 0 है यानी कि क्या है, ओमेगा cannot be 0, t can be 0, so this term will be 0 and phi then will be 0. So phi, initial phase, initial position, epo indicates 0 means the particle is at mean position. So when theta is 0, the particle is at mean position and likely to move towards right. Suppose n is the path and O is mean position, then when theta is 0, particle is at position O and likely to start its motion. Suppose moving towards right extreme position. If theta is 2 pi, means what? It has completed one complete oscillation, one set of movement, O to M, M to O, O to N, back again from N to O. This set of movement will be one oscillation and this one oscillation it has completed and it is likely to start the next second oscillation. It indicates if theta is 2 pi. 0 है ना, तो अगर वो थीटा 2 पाई है तो हम लोग बोल सकते हैं और 360 है तो पार्टिकल ने एक ऑसिलेशन कंप्लीट किया है एंड इट इज लाइकली टू स्टार्ट द सेकंड ऑसिलेशन मूविंग टुवर्ड्स राइट द मीन पोजीशन. इफ थीटा इज 90 सपोज, 90 मींस क्या, 2 पाई के 4 डिवाइडेड बाय 4 किया तो ये कितना आएगा, पाई बाय 2. So it has completed 1/4 oscillation. So when theta is 90, then particle is at position A, that is towards right extremity. It is at that position. ऐसा उसका meaning है. So this angular displacement theta omega t plus phi is thus called phase in SHM. It is 90. Then it is at positive extreme position and likely to move to the left towards the mean position. If it is 180, it has completed half the oscillation. We always assume particle initially moves towards right extremity, positive extremity. So it has completed the half oscillation and now it is at mean position, likely to move towards left. ऐसा इसका मीनिंग है. All these meanings and the description about phase of SHM is given in first paragraph on page 118. So you can go through page 118 and you can get about the phase in SHM. So this is about phase in SHM. We will define today few more quantities related to linear SHM by considering the equation of displacement to be the major equation, the basic equation. 1 minute. No one is there still. Okay. I will continue. So displacement is general expression for displacement A sin omega t plus phi. So this is the displacement at time t. If you find the displacement x dash, suppose after time 2 pi upon omega. So at the time instant t plus 2 pi upon omega. So you will get A sin omega t plus 2 pi upon omega plus phi. Substitute the value of t